Hey, good morning, everyone. Today we're comparing properties of two functions in different representations. Example 1, I do. The quadratic function is represented by the equation below, n of x equals x squared minus 5x plus 6, and the graph represents the linear function m of x. So down here, we're going to compare each quantity, n of x or n of 1 and m of 1 in this first case, and we're going to see if they are less than, greater than, or equal to each other. So n of 1, what I have to do there is I'm going to use my little workspace over here. N of 1, that means that I have to replace every x value. Let me move this thing out of the way. That means that I have to replace every x value that I see with 1. So I'm going to use my Desmos calculator over here. 1 squared minus 5. Replace that x with 1. Add 6. So that equals 2. So n of 1 equals 2. Let's make that a different color here. All right. And now I have to look at m of 1. m of 1, I have to go to the x value of 1, and then I'm going to go up to the function. So that means that m of 1, 1 equals my y value when x is 1, my y value is 3. So my comparison here, I'm comparing 2 to 3, and 2 is less than 3. My next statement, I am comparing the y-intercepts of each function. So let's start over here with the y-intercept of the graph. That one's typically easier to find. My y-intercept is where it crosses the y-axis, so I'm going to use this yellow dot here, and my y-intercept is at 6. So let's make that a different color. Y-intercept is 0, 6. And for my equation, my y-intercept of n of x, my equation, so to find the y-intercept, I could either choose to graph this, minus 5x plus 6, and if I look here, my y-intercept is at 6, so again, let's make that y-intercept is 0, 6. I graphed it and I looked where it crossed the y-intercept. I also know that this is in standard form for a quadratic, so the last number in standard form always stands for the y-intercept. So that's another little cheat to go through there. So 6 is equal to 6. Now the average rate of change. Average rate of change means that I should be using the slope formula. And remember, these values, 0 and 2, there are x values. So if we go here to our Desmos graph, and if I convert that to a table, I can look where x is 0 and where x is 2 and use that as my points. So I'm going to have x1, y1. I'm going to label them. I'm going to write them 0, 6 and 2, 0. So if I put that into my slope formula, that means that my y values, I'm subtracting the y values on top. So if I have x1, y1, x2, y2, I'm going to subtract 0 and 6. And then underneath, I'm going to have 2 minus 0. So let's make that a fraction here. All right, and 0 minus 6 gives me negative 6, and 2 minus 0 gives me 2, and negative 6 divided by 2 gives me negative 3, which should make sense because from 0, 6 to 2, 0, I'm going down. So that means that my slope is going to be negative. So let's make this a color, and we'll compare it. All right, green, that works. Okay, for the average rate of change for m of x, my graph, again, I have the same point, 0, 6, and then I have the point 2, 0. Okay, so I also can use my rise over run here. I can look at down 1, 2, 3, 4, 5, 6 over 1, 2. So down 6 over 2, that simplifies to -3. So again, I have the same values when I compare average rate of change. So that's what we did. We had equations, and then we had a graph to compare. We went through all these different features to compare them. This is going to be your job. You're going to have an equation here, which is different than the one that I had, and then a graph, or I'm sorry, a table to compare. What I want you guys to do is look at these two things. You're going to go to eClass and you're going to fill out the comparison chart for each one. It's going to be the same questions here. Good luck, everyone. And remember, daily sessions at 11 a.m. on Google Meet. Check your eClass page for the link. Bye.